We've all seen AI do some pretty incredible things, right? From writing poetry to helping doctors spot diseases. But here's the big question. Does it actually understand any of what it's doing? Today, we're diving into a really fascinating paper by Robert Pepperell that asks something huge. To get a machine with genuine, human-like understanding, do we first need to give it consciousness?
So, before we can even talk about machines, let's back up a step. What does understanding even mean for us, for humans? Instead of some dry, boring definition, the paper suggests we start with the actual experience of it. So let's try a quick little experiment together.
Okay, look at these three words on the screen. Fence, card, master. Your job is to find one single word that connects all three of them. Go on, take a second. You can kind of feel your brain churning, can't you? Searching around for that connection. There's that little bit of mental tension.
And there it is, post. Fence post, postcard, postmaster. Did you feel that? That little click in your mind when all the pieces just suddenly snapped into place? That little flash of insight?
That feeling is exactly what this paper points to as a key part of human understanding. See, it's not just about crunching the numbers to get the right answer. It's about the reward, that satisfying aha moment. So the big point here is that for us, understanding isn't just a process, it's an experience.
Okay, so to really get our heads around this huge question, the paper sets up a framework. It asks us to think about understanding in three distinct categories, and this is super helpful for getting clear on what AI is now and what we might be shooting for in the future.
So here are the three types. First, you've got natural understanding. That's us, the squishy biological computer in our heads. Second, there's artificial understanding. This is what we have today in things like our large language models. And finally, there's machine understanding. This is the ultimate goal, right? A non-biological machine that understands the world the way we do.
So just how different are those first two types, natural and artificial? Let's take a peek under the hood and see what's really going on when a human brain and a current AI try to understand the same thing.
So on the left, you've got a person looking at this wild, messy Picasso painting. Our brain is just flooded with all of this information at once. It's a holistic experience. Then on the right, you see a simplified look at a neural network. It's taking in data in a neat, orderly line, processing it step by step, layer by layer. The whole approach is just fundamentally different from the get-go.
This is a perfect example of our human process. When you look at this, you aren't just running a program to label shapes. No way. You're pulling in your entire life experience, your memory of a glass, what a key feels like, the idea of a bowl, and you're weaving all of it together to pull meaning out of the chaos. It's all about context.
And this brings us right to the core of the argument. Sure, AI can do things that look like learning, recognition, and even reasoning, but it's missing these three huge pieces of the puzzle that are so central for us. Consciousness, that aha moment of insight, and that feeling of reward. And that gap might be the very reason AI can feel so brittle, so lacking in basic common sense sometimes.
So, if insight and reward are so important, what's the fundamental ingredient that makes them possible in the first place? What's the secret sauce that separates our deep, messy grasp of the world from an algorithm's powerful but fragile calculations?
The paper's hypothesis is as bold as it is direct. The missing ingredient is consciousness. The idea here is that consciousness isn't just some philosophical cherry on top. It's the very engine that powers our deeper, more robust form of understanding.
This cartoon is just a brilliant way to picture it. Think of consciousness as your mind's ability to hold an entire universe of different ideas all at the same time. Thoughts about the artist, history, colors, your own memories, even completely contradictory stuff, like how a smear of paint is both just paint and it's also a lemon. Consciousness is what lets us hold all that complexity at once.
So this whole idea boils down to two key advantages that consciousness gives us. First up, motivation. That little aha feeling is a powerful reward that pushes our brains to solve tough problems. And second, integration. Consciousness is the mechanism that takes all those countless threads of information and weaves them into a single, coherent tapestry of meaning.
Okay, that's a really powerful idea. But if consciousness really is the key, then how on earth could we ever build it? I mean, let's just take a second to look at the staggering biological challenge we're up against.
Just think about this for a second. The human brain, the most complex object in the known universe, the thing that creates consciousness, it runs on just 20 watts of power. That is less than a dim light bulb. It's just wild.
Now, Compare that to the energy it takes to train just one of today's large AI models. We're talking over 600,000 kilowatt hours. The efficiency gap isn't just big, it's astronomical. It tells you that nature has figured out a profoundly different and way more efficient way to compute.
And the challenge goes way beyond just power consumption. We'd somehow have to replicate the brain's architecture of 86 billion neurons. And then we'd have to simulate its constant recursive feedback loops, a process that's completely alien to the way our current, mostly linear computers work. So, where does all this leave us on this quest for true machine understanding? Well, the paper's conclusion really forces us to think beyond just making our current models bigger and faster.
And this is really the key takeaway. Achieving true, human-like understanding in a machine might not be an iterative step. It might actually require a revolution, a complete rethinking of how we build computers from the ground up to more closely mimic the way a biological brain actually works. Which leaves us with this final, really provocative thought. If real understanding is tied to the conscious experience of insight, and that insight is driven by the feeling of reward, well then maybe the only way to build a machine that truly understands is to build one that can not only think, but can also in some way feel.